start?
You can start now.
Great. So good afternoon. My name is Barry Fitzgerald. I'm a Science Communication Officer at TU Eindhoven, and you're very welcome to this afternoon's lecture, which is part of the Stories of Change series. Now, the Stories of Change is part of the programme deeply embedded in the Drivers of Change, all brought to you by TU Eindhoven as part of Dutch Design Week 2020, which is, of course, all online. Now, before we introduce the speaker this afternoon, who's going to talk about a very interesting topic, just want to remind you about some of the great flagship projects and efforts that Eindhoven are making with regards to Dutch Design Week 2020. If you want to engage with the virtual program, you can do so at ddwtue.nl. There you'll find the program for all of the talks and projects, as well as the opportunity to engage in virtual tours and perhaps even to meet some of the specific demonstrators online for a personal chat. Now, today, as part of the Stories of Change, we're going to look at the energy transition and consider where we may go in the future with regards to energy management systems. And to introduce us to this very fascinating topic, we have a member of Team Red, which is one of the student teams based at the Eindhoven University of Technology. And the student who's going to be speaking with regards to this is Ana Suso Jimenez. Now, before I get Ana to say what she's going to be saying, just want to set the stage of why it's important to be talking about energy grid systems. Well, there's a lot of pressure to meet the sustainability goals as we move forward towards a less polluting method of producing energy. And this shift from the traditional energy system to these innovative, sustainable approaches is going to be slow, it's going to be complex, but it requires everybody to be part of the efforts. And Team Red, this student team, has a mission of breaking down the complexities to accelerate the inclusion of decision-making processes through the creation of a very cool, I must say, interactive energy grid simulation. So without further ado, I want to hand over to our speaker for this afternoon's talk, Ana Suso Jimenez.
Right, thank you. Team Red, as Barry already said, we are all about energy transition. For those that don't know exactly what energy transition is, basically right now we're running on a sort of old school fossil fuel system, and we're trying to move to a carbon neutral system. However, we have found out that is very difficult. We're not meeting the deadlines we want. So Team Red was founded to sort of accelerate that, create a possible solution for that. Before I dive into that, I would like to start off with a short video that I think really synthesizes who we are and what we do.
In this era of sustainable change, the legislation and societal norms are driving us towards a more durable energy landscape. Many ambitious goals and targets are being set for the future of our energy systems. However, making the changes to the current system is proving to be an incredibly complex task. The traditional infrastructure was built more than half a century ago, often with simple, one-directional connections from power plants to customers. With the increasing use of renewable resources, the conventional infrastructure limits the flexibility of the energy grid to accommodate these technologies. How can we redesign this system to better fit the present needs? Team Red is developing a data-driven platform to evaluate investment decisions for renewable energy technologies. We do this by creating a model which can assess the costs, benefits, and potential risks for such technologies, taking both economic and social aspects into account. We can make these assessments by running calculations based on data sources from the buildings, cables, and weather. This allows us to make predictions about the impacts that the simulated changes would have on the grid. With one device, it's possible to simulate the placement of different technologies on multiple buildings at once. So, instead of having to pay for the analysis of one building at a time, you can keep track of the overall situation. Moreover, the platform is offered with a user-friendly interface so that all the necessary stakeholders can remain involved, making our platform cheaper, easier, and more efficient. Support Team Red in our effort in taking a step towards accelerating the energy transition.
All right. So, yeah, I believe that we're all aware of this pressure that we now have to really go green, to shift our energy system to something more sustainable. And for that reason, I wanted to compile a couple of headlines that are circulating in the news right now. As you can see, they all reference to these deadlines not really being possible to meet. We know about the Paris Agreement, but deadlines like this to really cut down our carbon emissions are not really happening. They're not really happening in the time frame that we expect them to. But the question is, why is this not happening? Because for once, I think we can all agree that there is definitely an awareness about this issue. There is definitely people that care. If you're on social media, you will see that you often get news of like, oh, this person created this new crazy technology to harness energy out of, I don't know, something crazy. So we do see a lot of innovation happening in the sort of energy scope. We do see people coming up with solutions to create greener ways of extracting energy. But why is it that it's taking us so long to actually shift to depending on these new technologies rather than our old system? And the answer to that is actually quite obvious. It is complex, it is difficult. Like mentioned in the video, we have a system founded over half a century ago, and accommodating new technologies can be extremely difficult for this old system. So yeah, the bottom line is it is very complex. To paint a picture of just how complex it is, I have a diagram of what the current old system is. So of course we have the source, we have the, your usual fossil fuel mining or drilling. That goes to the power plant, and then from the power plant you get the electricity. It goes to the homes of people or to us here at the TUE, for example. So from this you can see that energy just flows in one direction. There is just one source and one sort of end user, and it goes from beginning to end. That's it. However, if you start putting new technologies in different points in this grid, then things get very complicated. So you can imagine, of course, if a building that just used to receive this electricity now becomes a generator as well, then what happens there? You no longer have the generator and the receiver, you have all things in between communicating with each other. So this creates this sort of intricate web where different buildings are kind of talking with each other, sharing energy in different ways. And this can be very beneficial for once, because that means, okay, if one building generates more energy, then another one can take from it. But on the other hand, what happens when, for example, I'm getting a bit technical, but the cables cannot handle two sources of energy or two sources of electricity? Yeah, what happens then? So that means we cannot just shift into this new system without first doing a lot of research, and that means a lot of time, a lot of money. It's just complicated. That's the bottom line. So that is where we come in as Team Red. As previously stated, we are a multidisciplinary student team here at the TUE. We all come from very different backgrounds, but we all found a same passion and a same mission within the team to really accelerate this energy transition, because we believe that we are capable of moving on to new technologies. We have seen that it is possible, but it's just taking too long, and that is really a pity that that is the issue and not a lack of innovation. We also believe that because this is an issue that concerns so many different people, so many different places, we have universities involved, industries, the government, society. We think that we as students have this kind of blessed space in there where we can talk to all of these different people and really gain insight into what they see possible, their perspective on this issue. So we believe that as a student team, we can really make a change and offer a solution for the energy transition problems. So now the fun part, that would be our solution, what we actually think would work for a problem like this. issues with the clicker. Oh, there we go. Yeah, so what you can see here is a table. It's an interactive table made up of a touch screen with a physical maquette on top and tokens. So basically the table and the screen show a simulation of a grid. In this case, we're working with the TUE grid, the campus grid. It is displayed there. The physical maquette just provides a kind of more understanding of the space and the buildings that make up of this grid. And then we have the tokens. And the tokens is what we created to symbolize new technologies that could be implemented. So if a person approaches the table, they can take the token, they can program it to be whatever technology they want. So let's talk about solar panels. Program that, put it on a building, and then see how the grid changes. So that way you have this kind of interactive space where you can play around, a kind of gamification of a grid. And people can just explore different technologies, different applications of technologies within this grid. What they would actually see on the screen and the data provided to them would be something like this. So they can see the campus, for example, and the buildings in it, but they also see the energy consumption of the buildings, for example, the energy generation, but also economic data. So for example, what costs you're actually saving by implemented X quantity of X technology. Also how many CO2 emissions you're actually reducing, again, by implementing X quantity of X technology. So they're fed all this data in graphs or simplified pieces of information. And I would just like to add to this that I am not a technical person. My background is architecture. I am not an energy manager. But if I see the screen and I see, okay, if you use 2 solar panels in the Vertigo building, you'll reduce CO2 emissions by this much and you'll save this amount of money. That is information that I understand. No matter my background, I can see that and I know what it means, and therefore I can create an opinion on it. I can be like, oh, well, that is a good idea, that is a good solution, that is a good alternative. We should use this innovation here, we should use this other technology here. So what this proves is that you can kind of show information in a way that is easy for everyone to understand. So the kind of behind the scenes of that interface is we gather all the boring data, the technical data that concerns the buildings, the weather, the energy and the grid, and we create calculations about this information and about the technologies that we want to implement. We create all of that, and then the interface just takes care of everything else. So the users, which can be anyone from grid managers, policymakers, campus owners, or the general public, they can just approach the table, the interface, and just play around with the simulation. And everything that is kind of too technical, too difficult, that is just taken care of by the model. So hopefully this just creates, like I mentioned before, an easier way to share information, to understand information, to really take this discussion to a level where everyone can participate. Also, sometimes there's issues when the grid managers that are super experienced with this is what they do, for a living. They know all of this technical stuff, but they don't know how to present it to the people that are the policymakers or the people that are making decisions on these changes. So there's just a lot of miscommunication that really can be simplified when you actually present the information sort of equally for everybody, and you take care of all of the calculations in the back. So basically a simulation. And that is what we hope to create, what we think really would help accelerate the energy transition. Since this project started 3 years ago, there has been, of course, a lot of progress, but a lot of iterations, prototypes happening. We're currently exploring how to make this work, what's the best way to make it work. Here's a couple of images from the beginning of our project all the way up until last year, Dutch Design Week, where we presented our first physical table to the public. Here's a picture of it. And yeah, we're still kind of trying to figure out how to continue this, how to go from here. Of course, in the past year, it has been difficult to work with a physical model for obvious reasons. So most of it has been done online, and a lot of work has been done on the data model itself. But yeah, we will continue to work on this, and hopefully it will go on and grow and become a more popularly used solution. Thank you for listening.
Is that the conclusion?
Yes.
Okay. Thank you very much for the presentation, Anna. It was very, very interesting. We're going to open up to some questions, and perhaps then maybe I'll just ask a question to start, just to kick things off, and then we can open it up to anyone who is tuned in to ask some questions. First of all, what I want to say is your logo is really cool.
Thank you.
I really like the logo. I love the idea with the E hidden in the logo as a plug.
I'm glad you saw that, because actually we've had a bit of issues with it lately, because we think that people don't notice the E when it's hidden. And we were trying to see how do we make it more visible, but the fact that, we get this confirmation from you that it does actually translate, that's great. That's great.
It does. It really does. So I got to say, it's very, very cool, I must admit. Now, in terms of the technology, I think it's really cool. And the idea that you can bring in these tokens which can mimic, additional energy options, renewable energy options.
Yeah.
What I would love to know is that, because this is a kind of a predictive model, do you also then, when you're talking about bringing in solar cell technologies or maybe a heat pump or battery technologies, do you stay up to date with the latest advancements in those technologies? So do you give people options, perhaps even with different types of solar cells they can include into the simulation?
Right, yes. So of course we have the technologies, but then, the token doesn't just mimic one technology. You have to set parameters for it, of course. You cannot say, replacing a solar panel, because, what are the dimensions of it? What are the, all of these parameters really affect what that technology, does and can do. So we are, of course, we break that down, and we also allow further customization of those technologies. So again, you choose the technology, but also exactly how it works, where it works, and set those parameters to make sure that the calculations actually work, because otherwise they don't really mean much. And when it comes to including newer technologies and staying up to date, that is very important. However, just for creating a more basic model, we're not focusing on some technologies, because you can argue that there are countless ways of generating energy. So we're not including everything possible, more the more commonly used things, energy, the solar panels, energy, batteries, just the basics. But I do think ideally, you need to be able to consider other technologies and kind of update that, because it's an ongoing thing.
So there is indeed the scope there to include and adapt the model to keep up with the latest advancements and trends with regards to renewable and sustainable technologies.
Yeah.
That's very, very interesting. So I'm going to open it up to if there are some questions from anyone who is tuning in to this Stories of Change presentation.
I do see a couple of questions. First one being, sorry, I don't have glasses, so I have to squint. You will be an architect. What can be your contribution to the transition from your point of view? This is a good one, because some people, when I tell them that I'm in Team Red and I'm an architect, they're like, oh, how come? But I do think there are a lot of things that go hand in hand. Of course, as an architect, you really dive into the sort of built environment, the bigger scope of the built environment. And a huge talk within the built environment is how to make buildings more sustainable, how to make them, for example, energy just sufficient, like self-sufficient, I mean. So from my point of view, I can kind of understand first of all, the importance of it. Second of all, how difficult it is to adapt certain buildings as well to certain technologies. So if we're talking about a grid, some buildings in that grid will be much better at using solar generated power, for example. Others are just not made for that. You cannot do it. So from my perspective as an architect, I just kind of see how, yeah, the built environment is also very complex, but also extremely important in the energy transition, and how we also, as architects, for example, need to think of that. We need to, when we create a design, when we build something, we do have to have in mind how that can possibly work as a self-sufficient energy building. Another question, how do you work together as multidisciplinary team? Oh, that's a good one. We all kind of, besides our studies, we also have, you know, other like passions, other interests. That's why I, as an architect, still join Team Red. And I feel like everyone within the team, they have an interest and they sort of took their own path within their own role within the team. So of course we have the people working in the data model, we have the people working with stakeholders with more business related stuff, and it all comes from our own passion, but also our background sometimes makes interesting discussions within the group. You know, we can discuss things from different perspectives. When we tackle a problem, everyone will have a different view on it, sometimes fueled by their study. So in that case, all we do is just respect everyone's interest, kind of keep one same mission, one same vision, and yeah, just kind of discuss and share ideas and perspectives. Next one, how do you define green energy? In other words, what makes energy really green? We thought gas was also very green in recent years. Yes. My definition of green energy, at least, I'm not a very technical person, but green energy would be something that doesn't have any terrible side effects or repercussions. So, yeah, sure, we did think that just because something is natural, comes off the earth, you can exploit it, that is technically green. However, if you're depleting a source that is not infinite, and you know, then it's just not sustainable. That's where the word sustainability comes from, that you can use something without depleting the sources of the future. So that is, I think, what really defines green energy, just something that is doesn't have terrible repercussions and that you can continue using without really taking away from the future. What political changes are necessary in order to realize the transition? How can the government participate in the most synergic way? I find this really hard to answer, first of all, because it's kind of hard to discuss politics on a global scale. You can talk about the government, but the government where? And from my background, I'm not European, I'm not Dutch, I'm from Colombia. And when I compare, you know, political issues regarding sustainability and energy over there, and I compare it to things here, I see such a huge difference that I find it really hard to answer this question, because I really, again, complexity. I think overall just awareness and people trying to commit to meet these goals is very important. We also cannot deny economic factors. We know that's really important. That's why part of our solution offers not only like, yeah, okay, you're reducing CO2 emissions, that's amazing, but we also say, look at the money you're saving, you know, look at the sort of more tangible things that you're creating. And I think that also kind of feeds into the political, I guess, creating more of a, better kind of system to deal with energy transition. I find it hard to, answer. To what extent is this an international initiative? I mean, to make transition only locally makes sense. First of all, the pressure to do that shift to energy, like that energy transition shift, it is an international goal. However, not everyone has kind of the same methods of doing it or the same like opportunities to do it. So I do believe that you got to act locally. You just got to focus locally. Of course, this is a global issue, but you cannot solve it globally directly because it is complex. It is different everywhere. It's not going to act the same. So I, just think globally, act locally, try to implement the solutions locally, and it'll translate it hopefully into a more international movement. How sustainability sensitive do you think your generation is compared to the majority in our country? Ooh, I do believe that our generation has way more pressure, way more kind of awareness of the environmental issues that we have, the sustainability issues. I know that since I was very little, I was worried by reading headlines like, oh, you know, we will not have this resource anymore. Oh, animals are going extinct, just a bunch of different things. And I think we were from very little like bombarded with this, so we know the urgency of it to the extent that me studying architecture and having to learn about sustainability, having to learn about creating self-sufficient buildings, that is something that I think in my parents' generation, they would have never studied. So I think, yeah, our generation has a lot more pressure. We're more aware of how fast we need to act more than anything. Last question, can the TUE campus really become sustainable without totally rebuilding it? I guess to some extent, yes, but that depends on many things. That depends on the technologies that are being created for energy generation, and also just understanding maybe if the grid can handle a good communication between buildings. So if there are some buildings that are really well equipped to be self-sufficient and they can also have an energy surplus and they can give to other buildings. So I think it is possible. However, to what extent, how long that would take, I don't have an answer for that, but I do think it is possible. Oh, 2 more questions. What is the role of human behavior when it comes to realized transition? These are deep. Well, of course, I think awareness is the most important part of human behavior. We need to understand that every action we do has repercussions. And sometimes it's really hard to grasp that when we're talking about buildings. You know, you're just talking about how a building uses energy. You in your daily life, you don't really think about that. But I think just having awareness, just really understanding how things work, creating discussions, because maybe those discussions will reach a person that will make decisions that are huge, that is really important. So I think just human behavior, man, awareness is the most important thing, and discussing things and really starting conversations. And the last one, back to architecture. Building in itself is not exactly very sustainable. Could you reflect on that? Absolutely. And we have this discussion almost every day. We understand that the built environment is extremely unsustainable. If we're going to talk about the amount of concrete that we have in the world, that's unsustainable. So overall, it's a struggle. We do have to kind of think how the materials we use to build, for example, can be replenished, how there can be a circularity, how we can reuse certain materials. So it's all a very complicated discussion because you have to weigh the pros and cons of everything. So yeah, if there's anything I've learned by studying architecture and being involved with the built environment is that everything is just about considering all the different aspects of sustainability. In some decisions, you will say, okay, for example, concrete is not very sustainable. However, it is very durable. It will last a long time. You don't need to replace it. Therefore, more sustainable. So everything is just about a balance of things and complexities, going back to the word complexity, but it's an important one. Oh, and last question. What is the goal you have as Team Red now? What do you hope to realize while you're in the team? The goal that we have as Team Red now is to really develop this model that we're working on to a point where it can be applied to multiple areas, multiple stakeholders. Of course, right now we're working with the TUE campus, but there's other people that might benefit from this that they're not necessarily a university campus. So I think just creating this model to a point where it can be used for different applications, different people, that is our goal. Me within the team at the moment is trying to, finish of course, the project for the TUE, but also trying to get more in contact with other possible stakeholders and kind of see how this project can grow and what we can do to actually make it grow.
Okay, is that the last question?
Yeah, I believe so.
That's the last question. Well, I have one more question, and it links just to what you just said. What would you say to any students who are interested in becoming part of Team Red in the future. So imagine this is your selling point. What would you say to them about being part of the team in the future?
Well, I think we're doing something great. I think we're tackling a problem that really urgently needs to be resolved. I feel like on the one hand, innovation is very important, but I think in the world we're seeing a lot of innovation in other aspects. And I think what makes our team special is that we're trying to target a problem that urgently needs to be resolved to really push kind of innovation further. So I would say if you have that same mission, if you feel that same urgency, if you feel like things are kind of unnecessarily complicated at the moment when they could be simpler, then Team Red is a place for you.
So if anyone wants any information about Team Red, whether that's prospective new students or just anyone, where should they go to get this information?
Mostly our Instagram, Red Smart Grades. Smart Grades, oh my God. Red Smart Grades. So yeah, follow us there. Yeah.
And do you have a website and email address?
We do have teamred.nl, and that is our website, and info@teamred.nl is our email. So if anyone wants to contact us via email, they can also do that. Yep.
Excellent. That's great. Well, Anna, I want to say thank you very much on behalf of everyone in the Stories of Change, Drivers of Change at TUE for taking the time to present your fantastic story and your work with Team Red. I think it's fascinating and it's something that's urgently required, not just now, but of course for the future, and wish you all the best with the rest of your efforts with the team.
Thank you. Thank you for having me.
You're very welcome. Just to conclude, I just want to remind people that there are more energy team talks going to be taking place over the course of the day as part of the Stories of Change, and they'll take place this evening from 7 o'clock, and one talk is going to look at metal fuels as a sustainable fuel, and then thereafter there will be a second presentation in relation to thermal energy being extracted from water. So keeping that theme of energy and sustainable energy moving forward for the rest of the day as part of the Stories of Change. I hope you've enjoyed this very interesting presentation on Team Red and sustainable energy and energy grids. And I hope that you engage with the rest of the programme for the Stories of Change, the Drivers of Change, and of course, all part of Dutch Design Week 2020. And wish you all the very best. Thanks for tuning in.